So, welcome back to the last part of applications 8.5 matrices and its determinants. You did it. This is the end, okay? But this one's going to go a little bit long and it's a little bit complicated. So bear with me, okay? Cramer's rule. And you know that matrices are used to solve linear systems, as you've been noticing. You've seen these before, right? So I think before, when I introduced to you the inverse and also the determinant, I showed you how, you don't need to write this part down really, okay? I showed you how right here, like the solution, when you try to solve this linear system, I think I explained to you how x becomes this. Like when you try to solve for x, you try to get rid of the y's, you have to multiply it top and the bottom by b1, negative b2, negative b1, and you do all your calculations, and this is what you end up with. And I specified how a1 and b1 minus a2 times b1 cannot be 0 because that's the denominator, right? Well, this is going to come into play during Cramer's rule, okay? So let's get started on Cramer's rule. So this can be expressed as what? As the determinant. So this is a little bit, you're going to get a full explanation real quickly, but I'm going to show you the basic Cramer rule determinants and how this is connected. It'll all make sense, okay? So let's try it this way. So remember, when we're solving a linear system or any kind of matrices, we're trying to solve for the x and the y that make this true, right? The solution, okay? So here we go. So x, you see this right here, this x, it's actually, as we have here, this x is actually the determinant of your C1, C2, B1, B2. So it's kind of like a partial determinant. We're going to see all this, how it all works out. But you know your A1, B1 minus A2, B1? Did you know that's actually the determinant of your coefficient matrix? Yeah, okay. And what do you think then, how does that make you feel about y? How do you think this came about? Think about that. It's a 2 by 2 matrix again, right? In the determinant. So the y is actually the determinant of a1, a2, so your coefficients of your x's, and the actual constant c1 and c2. And your denominator, again, it's the same thing as x, right? Because it's a determinant of your coefficient matrix, okay? So now we're going to go through the process of how this is used to solve and how we actually lay it out, okay? It's a little bit of a long process, but I know you can do it, so bear with me, okay? All right, so let's actually go ahead and solve a linear system using the Cramer's rule. You're like, when would I ever use this? It's actually kind of cool, okay? So bear with me. Let's do a small one first, okay? Let's do a small one first here. All right, so let's actually do one like this. I'm going to use my marker here. Where did my marker go? I dropped on the floor, so I need a pencil, okay? So watch this. I have a linear system, 4x plus 2y. Okay, 4x plus 2y. Let me focus that. Is equal to 12. And 2x plus 5y is equal to 10. Okay? So this is if I were to draw a matrix, it would be a 2 by 3 matrix. And you can do this by RREF and all that good stuff that you know how to do, correct? But we're going to try a different way use Cramer's rule to solve. Again, we're solving for all the true values that make this equation true or where these two situations meet, okay? So let's set it up. First step, I'm going to calculate what's called the determinant. Now, the determinant is for the what? It's actually for the coefficients. Okay? So first, find the D. The D is actually the determinant of your coefficient matrix. Do you see that, you guys? All right? All right. So now, well, if you want, why don't we write a matrix? 4, 2, 2, 5, 12, 10. But I'm going to make this kind of like put all the things that we know together. We know that this guy times xy is equal to 12, 10. I want you to understand that this is A's and these are the B's, okay? and also that these are the C's in terms of Cramer's rule. Okay, so now we're going to basically use that. See how this is the actual coefficient matrix? So we're going to calculate that. That's going to be 20 minus 4, so it's going to be 16. Okay, so 20 minus 4, so D is equal to 16. Okay, that's the first step. Second step is for me to calculate the derivative. We're going to calculate the derivative of x. Now, what does that mean? If you look back on your Cramer's rule, go ahead and look at what x was. So if I'm looking at the Cramer's rule, what I just calculated right now is this here, D. So this right here is my D. You see this guy here, he's my D sub x. You see this guy here, what do you think this guy is? He's D sub y. And this guy is my D. So you see how x is composed of D sub x, the determinant of this special x, determinant of the special x, and the determinant of your coefficients. Okay, and same with y. Okay, so that's what we're doing right now. We're calculating little by little. Okay, so we're calculating little by little. D sub x is this. Now, did you know, oh, so actually I'll write this for you. D sub x is going to be C1, C2, B1, B2. What does that mean? As I told you, x values are your A's, y values are your B's, okay? So here's what we're going to do here. C is always your constant. So we're going to say C1, C2 is your 12, 10. So if you're calculating the x, you replace x with the constants. But B1, B2 becomes 2 and 5. Okay, it's the y values. Okay, now when we calculate D sub x, what do we calculate? It's 60, right? 60 minus 20. So D sub x is 40. So these are the values that we're going to have to use. So we're going to circle them. Okay, so that's 60 minus 20. Okay, third step, what do you think we calculate next? D sub y. Smarty pants. So now again, determinant. But remember, we're solving for y, so we want to leave the x values alone. Okay, the coefficients that are in front of the x, we're going to leave alone. Okay, and the second column, which should be the y, gets replaced by the constant. So I'm going to put like a little mark on here, so that you know which section to replace. You see how these replace, and these are the values of the y values. And these are the values of the x values. Okay, so if you're looking for y, y gets replaced. If you're looking for x, x gets replaced with the constants. Okay, so let's calculate d sub y. D sub y is equal to 40 minus 24, which means it's equal to 16. Okay, all right. So far, does this make sense to you? If this does not make sense to you, why don't you tap a neighbor or call me and ask me some questions, okay? All right, now how do we use all this to actually solve for the x and y, right? Our solution. So we're still looking for our solution, right? So what do? The last step is this. X is equal to d sub x over d. Y is equal to d sub y over d. So what's d sub x? We go 40. What's d? 16. What's d sub y? 16. What's d? 16. And that's it, voila. So y must be 1, and this guy we can just simplify, so it's going to be 5 over 2. So our solution to this linear system is 5 over 2 and 1. Voila. That's it. That's how easy this is. Okay? So I'm going to do another example. So if you need another example for a 3x3, make sure you watch the next video. But otherwise, good luck with your